Hello and welcome to our instructional video on solving for the variable in a linear equation. In this video, we will be solving the equation 4 times x minus 1 equals 11. By following a step-by-step process, we will determine the value of x that satisfies this equation. So grab a pen and paper and let's get started. Step 1. We start with the equation 4x minus 1 equals 11. Our goal is to isolate the variable x on one side of the equation. To do this, we first need to get rid of the minus 1 on the left side. We can achieve this by adding 1 to both sides of the equation. So we add 1 to 4x minus 1, and we also add 1 to 11. This action will cancel out the minus 1 on the left side. Here's what it looks like when we perform the addition. 4x minus 1 plus 1 equals 11 plus 1. Notice that when we add 1 to minus 1, it becomes 0. So now on the left side, we only have 4x remaining. On the right side, 11 plus 1 equals 12. As a result, our new equation is 4x equals 12. This is an important step because by getting rid of the minus 1, we have simplified the equation, making it easier to solve for x. Step 2. In step 1, we simplified the equation to 4x equals 12. Now we need to solve for x by isolating it completely on one side. To do this, we divide both sides of the equation by 4, because 4 is the coefficient of x. The coefficient is the number that is directly in front of the variable x. So we take 4x on the left side and divide it by 4. Similarly, we take 12 on the right side and divide it by 4. This action will cancel out the 4 in front of x on the left side. Here is what it looks like when we perform the division. 4x divided by 4 equals 12 divided by 4. Notice that 4 divided by 4 equals 1. Therefore, on the left side, we are left with just x. On the right side, 12 divided by 4 equals 3. As a result, our final solution is x equals 3. This means we have successfully isolated x and solved the equation. The value of x is 3. This is the final step. Thanks for watching. I hope this video has helped. And if it did, please drop me a like.